Everybody, I'd like to welcome Michael Eddington, Demystifying Fuzzers.
How's everyone doing today? I got lucked out today. I got the awesome talk slot. It's like the 11 p.m. right before, or 11 a.m. right before lunch, which means I get to sleep in a little bit. If I go too fast, you can all go to lunch early. No one's really going to complain. I kind of like that. I tend to talk fast, so we may blow through this deck fairly quick. I really hope you guys have some good questions. I love answering questions, so definitely, hopefully there's some good QA at the end. My name is Michael Eddington, and I wrote the Peach fuzzing platform. I've been doing research into fuzzing for the last 4 or 5 years. And when I'm not doing that, I'm a security researcher, security consultant with Leviathan Security Group up in Seattle. And for like the last, I don't know, maybe a year and a half or 2 years, I'd say about 70 to 90% of the gigs I've been doing have been pure fuzzing type of work. Kind of varying from file fuzzing to OS level fuzzing at protocols and things of that nature. So today's talk is kind of centralized around kind of talking about the different fuzzers that are out there, kind of what your choices are in the fuzzing realm, and also kind of how to adopt a fuzzer for your corporation or for your use without losing. You know, kind of how to do that without getting fired or getting a good result or return on investment. So first off, I figured we'd start out by talking a little bit about how fuzzers work and kind of what we're doing here with this fuzzers. I'm not going to spend a lot of time on this because hopefully, there's been plenty of talks at Black Hat on fuzzing. In fact, the talk right before me was talking about some fuzzing along with pen testing. And essentially what fuzzers are is they're basically little engines that can consume data, modify it in some sort of hopefully interesting way that we can then send to an endpoint that will hopefully blow up. And hopefully will blow up in an interesting way that could be exploitable or is otherwise interesting, perhaps a denial of service attack. Nowadays, we have these things called smart fuzzers. And smart fuzzers not only will consume some data to modify or generate data on its own, they tend to have these little extra bits of information, typically like data type models or grammars that can kind of help it kind of target data inside of a file or a protocol to better mutate things, like for example, knowing type information. So at the dumb end of this scenario, and the way things kind of have started out, and still kind of occasionally occur, a lot of people still run dumb fuzzers, is we do things like D-word slides. Now with dumb fuzzers, we tend to not know anything about the data we're consuming, and therefore our options on mutations are somewhat limited. So a typical one is we might pick a D-word type of number or byte sequence and slide it across our byte stream. And as we slide it across our byte stream, we change the value of numbers, strings, enums, whatever it might be, and hopefully cause different paths in the code to be executed and hopefully trigger some faults. Additional things we can do for dumb fuzzing that are fairly easy is we can do bit flipping. Pretty simplistic, once again. Our goal with bit flipping is to cause changes in the program that are hopefully exploitable. Now there are problems with dumb fuzzing. Obviously, if we're changing bits in a file we know nothing about, we can run into the classic problem of a Crc check. Now Crc checks in files are essentially, if you were to think of adding up all of the bytes in this file as one and maybe XORing it in a certain way, or XORing all the bytes together in a certain way, you can come up with a very simple little kind of a 32-bit number that kind of represents the overall value of the file. If you change something in the file, like 1 byte, you're going to change the Crc value. In fact, in recent years, as fuzzing has become very popular, I'll do code reviews, and I will literally see in the code a section of code commented like, added anti-fuzzer CRC. Kid you not, the anti-fuzzer CRC. Traditionally, CRCs were added simply to verify that a file had not been corrupted or modified in transit. Nowadays, people add them to defeat dumb fuzzing. So, dumb fuzzing problems, once again, we have uninformed mutations. We have a limit on the amount of mutations that we can do intelligently since we know nothing about the structure, and we get defeated by any form of checksum, crypto, compression, or any other sort of interesting modification like that. So enter the world of smart fuzzers. So smart fuzzers are the things that have really taken off in recent years. And the things you'll probably see at least 5 talks on this year, whether it's Charlie Miller talking about fuzzing on the iPhone, or Masano, who's just up here talking about quickly fuzzing protocols you know nothing about, or GMI, or anything else. And really the core to smart fuzzers is being able to know more information about what we're fuzzing. And you generally start there with type information. So the first level for smart fuzzers is, instead of having just a binary string or binary array, we want to know the type information. So like int, enum, flags, strings. It's also really cool if we can fix up CRC. So as we're fuzzing our data, the first thing we're going to want to do is, if there's a CRC, we want to fix that CRC. In fact, you can take dumb fuzzing and extend it and make it just a little bit more smarter just by adding CRC fix-ups if you know there's a CRC there. Additionally, other things that are extremely nice to know are relationships, because ultimately a lot of the things we're trying to trigger when we modify a file, or we're trying to hit relationships inside of the data. For example, the length field in front of the string field. That's a fun one to screw around with. Also, if there's a length field in front of a string field, it's nice to know that we have to change both of those to make our string longer and longer and longer to get past certain types of validation. Taking it a little bit further, we have state awareness. Even fuzzing things like COM objects, you need some amount of state, because you might need to call an initialization function prior to calling function A, function B, function C. For example, if you wanted to fuzz the COM QuickTime control, aside from loading that control up, waiting for it to initialize, you need to set a property for the file you want to play, and then you need to start calling methods on the player saying things like play my movie, which maybe you would fuzz, to actually get it to really be parsed. Obviously, with network protocols, state is very important. If you want to do anything other than fuzz the first couple packets in a protocol, you're going to need to know how to do things like inject authentication, move session IDs along through your packets, and have some sort of concept of packet sequence. Additionally, one of the big things that we hopefully win on smart fuzzers is data mutation. Hopefully we can do a much, much better job of doing intelligent data mutations by knowing type information. For example, on this top portion is a numerical fuzzer, would be edge cases for numbers. And every little yellow block there represents numbers around an edge case for numbers, whether that's 0 through 50, numbers around 127, 255, 32K, 65K, and so on. By knowing a number exists in its size, we can apply these edge cases very quickly and hopefully trigger very interesting integer overflow type scenarios or integer promotion issues, things of that nature. Additionally, we live in a world of string protocols and string tokenized, strings that are tokenized and parsed for meaning. So for example, if we were to look at that very simple query string value down there, where we have basically a key equals value, as you look at that, you can pretty much parse that in your head. You understand that, maybe first we hit the question mark, you kind of see these equal signs and stuff, but you notice the ampersand seems to separate two key equal value pairs and so on. You can kind of break that up. Well, the fuzzer should be able to do that for you as well. So hopefully we can also add in very interesting string mutations that take a lot of work off your hands. So now that we know what fuzzing is about, the question is, why are we fuzzing? Well, obviously, we're fuzzing and doing all this because we want to find bugs. Now, for fuzzing in general, one of the big wins for fuzzing traditionally has been kind of cost per bug. So fuzzing essentially started in the security researcher's hand, and what he wants to do is he doesn't want to sit all day in IDA to try and find a bug. Instead, what would be really cool is if I can just do some D-word fuzzing and have like 5 or 6 or 7 or maybe 100 crashes fall out. Because that's really cool, because the cost of my time versus the return on investment was pretty high for that. And we do find bugs with fuzzing. It tends to be that it's very rare that you run a full-on fuzz run on something and you don't find something. Typically, the only time that occurs is when you're testing something that has been supremely heavily tested and has not had a new version in a while. So hopefully, when we talk about corporate adoption, we can also say things like return on investment is high for fuzzing, cost for entry is somewhat low, or it is after you train your people up on them. And there can be a good alternative, and especially in certain economic times like these, to having a full-scale review done. Not that I would ever advocate just doing fuzzing as opposed to a security review, but it is a great addition to a security development lifecycle. So the next question is, what type of bugs are we finding? Now that fuzzing has become the buzzword of the last couple of years, everyone wants to fuzz everything. Articles get written in the CSO magazines and mandates come down to add fuzzing to your SDL. But the question then becomes, what are we really doing with fuzzing? Well, with all this input kind of testing, traditionally the types of bugs that would fall out are kind of in two categories: bugs that cause crashes and bugs that cause denial of services or hangs. So traditionally when we talk about fuzzing, we're talking about things like memory corruption issues, buffer overflows, integer wraps that cause memory corruptions, things of that nature. And it tended to be that the things that were most interesting to the security personnel were the things that were exploitable kind of memory corruption issues, such as heap overflows, stack overflows, and things of that nature. Now, certainly as we progress, fuzzing has kind of started to be used for a lot of different things. For example, your web application scanner probably says it fuzzes. We have web proxies that fuzz because they're doing fault injection. So really what it comes down to is anything that you can programmatically test for finding some sort of exploitable condition and fits well for doing mass kind of scale input can be done with fuzzing. I tend to say that before you start a fuzzing project, one of the first things you need to do is ask yourselves, what kind of bugs am I expecting to find? And can my fuzzer find those bugs? Can I write an addition to a fuzzer that can programmatically find that without human intervention? And things like cross-site scripting bugs tend to be one of the harder classes to find, simply because, if anyone has ever done a lot of web testing, you sit there and you do all sorts of weird injections, you look at the return and you use that to base your next set of injections on. You're really fighting against filters and custom logic, and only it tends to be the easy cross-site scripting bugs will fall out from basic fault injection. For myself, pretty much all the fuzzing that I do is on native applications, looking at native protocols, and trying to find more of the traditional class of bugs. So this leads us into the types of existing fuzzers. And I'll kind of start with like two basic buckets: open source fuzzers and commercial fuzzers. And from there, we can kind of talk about file fuzzers, network fuzzers, general fuzzers, and custom fuzzers. Now, custom fuzzers are ones that I consider kind of one-off fuzzers. For example, when someone releases the JavaScript HTML fuzzer of the week, or an ActiveX fuzzer of the week, or whatever, insert my custom little fuzzer here. So personally, I'm an advocate of generalized fuzzers, and the reason is that your time and energy for adopting technology is limited. And the nice thing with general fuzzers is typically general fuzzers have some sort of pluggable I/O interface that allows you to target multiple different endpoints. So for example, with Peach has a pluggable system called Publishers that allow you to not only target network apps, but use your same level of knowledge with the application to hit files, to hit RPC, to hit COM, DCOM, or whatever you end up wanting to write. It tends to be, however, in the open source field, that the majority of fuzzers tend to be very specific fuzzers. And the reason for that is they tend to have been written a lot of times for talks. So, every year as we go through the Black Hats and the CanSecs, we get our new round of fuzzers that get released. I think this year there's at least 5 different fuzzers being released at Black Hat that I've been able to count. And the question kind of is, obviously they give a nice talk, they find some bugs, there's lots of rah and energy. So the question is though, should you actually adopt that fuzzer? How long is that fuzzer realistically going to be around? And it turns out kind of the fuzzer lifecycle for open source fuzzers is, hey, I have a great idea to find a bug, to give a talk, I give my talk, and then I discard my fuzzer. And that's kind of the sad nature of kind of the open source fuzzer world right now is there's pretty much, 2 types of fuzzers. The fuzzers that the security company uses internally that they wrote and decided to release, typically with a paper, that gets, maintained maybe a little bit more than some other projects, but really only enough for them to do their internal work. It's not really, a massive project. It's not something they expect to really push to external users. It's something they're giving back to the community. And then there's the I want to give a talk at Black Hat fuzzer, where someone sits down and says, hey, I haven't really seen anyone fuzz VoIP today. So we're going to throw together a fuzzer, we're going to give our talk, we're going to release it, and then that's the end of that. Or maybe you're writing a book and you need to release some sample code and things of that nature. So that makes also adoption of fuzzing difficult because there's a plethora of fuzzers that come and go. And what's left is, well, who knows what's left? And that's kind of what today we're going to talk about. We're kind of going to go through, and I'm going to talk about some of the common fuzzers that are out there, and we're going to start talking features. Now, I'm not necessarily going to advocate and officially advocate one of these fuzzers to use, but hopefully you can take all the different things we talk about today and apply that to your decision-making process on which fuzzer to pick up. So here's a brief little list of some of the fuzzers that are out there, and I kind of split them up by the type of fuzzer. And you can see there's some names you probably know in there, like GPF, EFS, the Art of Fuzzing fuzzer. There's Peach, there's Spike. And you might wonder, well, of these, which ones are still maintained? So it turns out not too many of them are still maintained. In fact, I can really only classify 2 of these open source fuzzers as actively maintained. And by actively maintained, I mean the developer is actively releasing new features for the fuzzer currently. For example, Sully, which is just still widely popular from the book that occurred, was written by Pedram back in 2007. You can't even download a full release of it. You have to check it out of its Google Code repository. And Pedram has said that he's not really intending to do too many more major revisions, if any, probably just because it does what he needs it to do. And at this point, he's moved on to other projects. Other fuzzers haven't come out with a new version in like 2 or 3 years. Pretty much the only one that's pretty current is Fuzzware and Peach. Fuzzware actually, in fact, just came out with a nice new update and web redesign like 2 weeks before this conference. And you'll notice that all these custom one-off fuzzers, none of them have been maintained recently. And pretty much most of these one-off ones were fuzzers that were written specifically for a talk or the bug hunt of the month and never went beyond like the 0.1 revision. So enter commercial fuzzers. So pretty much there's only like 3 commercial fuzzers that kind of showed up on my radar. And this may just be poor Googling skills or lack of awareness on my part, but really it seems like there's only 3 major players in the fuzzing space for commercial. So first up, we have Moo Security, which changed its name to Moo Dynamics. I think sadly through all my slides, I still call it Moo Security because that's just kind of how I know the company. So no offense to the Moo Security people if there's anyone here. They are now Moo Dynamics. They are network only. In fact, you don't buy software from them so much as you buy a physical appliance from them. So when you go and you pay them your stack of cash, they will ship you like, I think it's a 2 to 4U rackable Linux box, I think it's Linux still, that has their software on it. And Moo originally had largely targeted network devices as kind of their big strong suite. So on the device, there's 2 Ethernet ports and a power plug, and you would literally plug your router or your switch into the fuzzing box, plug the Ethernet cables through, and hit the magic go button and say, go fuzz B-tree or DNS or web proxying. And it will run off and run through its test cycle and so on and so forth. Now, Moo is still actually a fuzzer. So one of the things that they give you when you buy the protocol suite is they give you their smart fuzzer grammars and data definitions. So in theory, you can go in, and if you have a custom modified version of a protocol, you can modify their grammar, and their engine will run, and you'll get somewhat different test cases that will target your stuff. The downside of having a physical box is obviously you have one physical box. You can't really scale that into a parallel type of mode or things of that nature. Next up, we have a company called BStorm, or a product called BStorm. And I think BStorm ends up being the most like kind of a traditional fuzzer set. It gives you tools to write basically XML-based data models of things. You can buy packages of pre-made definitions for files and for network stuff. It is a general-based fuzzer. And it's software-based. You run it on your Windows box or whatnot, and it will do your fuzzing runs. And also, it's the cheapest of the 3 solutions. And I'll talk about price towards the end. And next, we have the fuzzer that's not really a fuzzer, Konomicon. Now, the reason I say it's the fuzzer that's not really a fuzzer is So Konomicon back in the old days was Protos. Does anyone here remember Protos testing suite? I see a few hands. Now notice that Protos testing suite, it's not Protos Fuzzer. The Protos testing suite, what would happen is when you got this, you would basically get a tar file that had, say, 10,000, 20,000, 30,000 test cases pre-made, and an application to run your test cases against, say, LDAP or SNMP version 3, or whatever protocol you were testing. So while on the back end in the company, in a vault, they may have a fuzzer engine locked up, and they may have data models locked up, but you never see that. What you end up getting are pre-generated test cases. Now, the reason they're still kind of classified as a fuzzer is, these test cases, pre-made or not, still basically fuzz an application or a protocol. Now, the major downside to this, of course, is you can imagine if you have a modified version of the protocol. Let's say you're Microsoft and you're writing the new version of all the protocols. Well, you can't really use Konomicon efficiently because while they do allow you to add specific test cases, you don't have any sort of generalized grammar you can modify and regenerate all the test cases. Now, this also means that you're also limited to whatever type of configuration Konomicon thought you were going to have. For example, I was talking to a guy who took my Peach Fuzzer class the last 2 days, who's fuzzing Ike, and was telling me that when they evaluated Konomicon, they have an Ike fuzzer. However, their Ike fuzzer was locked down to very specific parameters. Like you could only do certain types of encryption was used on that, and it wouldn't really go beyond that. So that could be a problem. So Konomicon, as much as they have probably the biggest research, one of the larger research groups in terms of how they do test cases, is also probably the most limiting fuzzer in the commercial space. So the one-off fuzzers like Dom Hanoi, Hamachi, I think everyone heard of kind of some of these. These were kind of made famous, a lot of these by H.D. Moore actually, for some of the Summer of Bugs series of stuff. And so on one hand, none of these are maintained anymore. On the other hand, because they were kind of custom, quick one-offs meant to find kind of low-hanging fruit type bugs, the mutations involved in them don't really go very far. Like they're fairly simplistic fuzzing examples. Like if you were to load up these fuzzers and look at how they mutate, you're going to see they have basically a static set of, okay, we're going to take A and we're going to copy that a whole long string and do this and that, but it doesn't really get beyond kind of basic mutations. And this is also something you see from first generation fuzzers or fuzzers that don't get updated much, is the developer never has a chance to move past the very basics. There's also a huge discrepancy between kind of defensive fuzzing, I would say, and like offensive fuzzing. Like if I'm a security researcher, all I need to really do is find the one bug to make my name. As a corporate entity or the defensive in the SDL, you need to find all the bugs before that security researcher finds his one bug. And so really what you're looking for is something that's got more maturity and more coverage and more ability to be maintained. So creating new fuzzers. So another thing that I do a lot is I help companies adopt fuzzing into their SDL, or I come rescue their fuzzing effort, or I come in and tell them their fuzzing effort is not going so well. And a lot of times what I see companies do is they're like, well, fuzzing's really easy. All we're really doing is we're modifying some data and crapping it out to a target. I can do that. Heck, I can have my tester write a fuzzer in like 2 days. It's going to be awesome. And we're going to save money, and we won't have to use some sort of sketchy hacker tool. And we won't have to pay Moo Security $100,000. Well, the problem is that while fuzzing as a concept is easy, fuzzers themselves are not really easy, or not really that simplistic. Once you start collecting type information and this and that, you start finding that we're really doing some complex stuff. If you think about all these different types of data mutations and how you modify data models and state models and deal with protocols, you quickly find yourself getting overwhelmed. Additionally, a lot of companies don't realize initially that aside from the initial development costs, they got to test this thing. And suddenly, after they've written it and like 5 or 6 departments want to pick it up and really use it, they've got quality issues, they've got training issues, and now they got to maintain the thing. And it tends to turn out that that rockstar developer or tester who wrote the first version wants absolutely nothing to do with its maintenance. And now we're stuck. But I'll tell you, the biggest thing that I find with custom one-off fuzzers in corporations is they're broken. There'll be some bug in it that will produce the wrong results that ruin your coverage. And this is also true for people using other solutions and write their definitions incorrectly, but it's much, much worse when your tool is incorrect. For example, I might walk into a company and say, give me all of your int32s. And I expect at least 500. If we're gonna fuzz an int32, and you're gonna give me less than 500 numbers as your edge cases and variances, we're gonna have to talk. And what will surprise me is I had one case where I asked for it, and I got 10 numbers. And 4 of those numbers were the same. And I kind of scratched my head, and I went, how long have you used this fuzzer? How many protocols have you fuzzed with this fuzzer? And I was astounded to find out quite a lot. And I was thinking to myself, wow, it's a lot of wasted resources. Other things that you might find is the application treating end units incorrectly. Heck, I even had one fuzzer, and this blew my mind. We were running this fuzzer, and someone realized that all the files it outputted were the same. And I went, scratch, wait, the same? Sure enough, the MD5 signature of every file was the same. It turns out this fuzzer marked every field non-mutable by default. And I went, non-mutable by default, that doesn't even make any sense. And yet, this company has spent 6 months fuzzing 30 or 30 file formats with a fuzzer that didn't change files. Obviously, we have a problem there. So my huge recommendation is, if you can, build off something existing, build off something good, and adopt something that's to be maintained. Okay, so now we're gonna talk about kind of the fuzzing process. And each step, I'm gonna kind of pull out features of the fuzzer. And the process overrun is kind of like this. It's it should be hopefully fairly obvious: investigate, modeling, validate, monitor, run results. And so first up is gonna be the investigation portion. And I find a lot of times people skip this and jump right into dev and then kind of get a little lost. So I kind of like to do at least a little bit of investigation. Obviously, we're not writing the Apollo moon landing software or production software, so we can kind of be a little jippy on things, but it's good to at least start and select our targets. A lot of times you have a large attack surface for something, and you need to narrow down what you're initially going to start hitting. We also want to map our fuzzer capability to what we're going to do. For example, if you want to start doing embedded fuzzing, you're going to need some features from your fuzzer that maybe don't normally exist. If you're going to have fuzzing on a system that's non-standard, like AIX or Solaris, you're also going to need some features and some runtime support that may not be supported. Now, aside from fuzzer features, actually picking your target can be really fun. The first thing I like to do is I like to pick the oldest code I can find. And I love old code. And the reason I love old code is because companies love to test the new code. And they really hate to spend resources on the old code that should already have been tested but wasn't. Or it was tested before we had certain types of exploitation techniques, and therefore is probably target ripe or target rich. I also like to find the really weird, complex parsers that should never have been written in the first place, or should have been used using a library. And of course, you got to find things that have good attack surface and good security boundary crossing. Certainly it doesn't make a lot of sense to fuzz things that don't cross good security boundaries. The next thing we're going to do is we're going to have to take whatever our target is and we're going to model it. And when I say model, this is when we're going to build kind of that type information out. We're going to build out that relationship information. And we're going to start really building our fuzzer. Now, before we go all wild with modeling, which can take some time input from you, it's actually one of the longest, it's going to be the longest process part of our fuzzing development cycle. I kind of want to mention something that Chris Clark from ISEC loves to tout out whenever I talk fuzzing, which is, and he calls this the pyramid of fuzzing. It's the FDA non-approved fuzzing model. And pretty much what the model is it's kind of a QED thing. It kind of says, before we spend a lot of time developing our smart fuzzer, run a dumb fuzzer. So as I talked about building your fuzzers, really the first thing that happens once I have my target is the very first thing I do is I take whatever fuzzer I'm using and I tell it to run in some sort of dumb mode. and then I go and write my real fuzzer. And the nice thing about that is I don't lose any time. And as I do generations of my smart fuzzer, I can slowly replace the dumb fuzzing. But you never know. You may be writing your smart fuzzer and going like, oh, this is gonna be awesome, I'm gonna find so much stuff. And you may find like 5 bugs just from the dumb fuzzing. You'll be so happy. And that'll motivate you to continue on. As I will also point out with modeling, since it is the longest time spent here, this is also the biggest benefit you get from buying a commercial solution, because the commercial solution, one of the biggest things you get from it is pre-made modeling. Oh look, I even have a slide for that. Additionally, modeling between all these different fuzzer tools tends to be widely different. You have a wide set of options on how you can model and what your fuzzers allow you to model, and the tools provided for that modeling. For example, I've had to fuzz some event log formats where the structure definitions are like literally 100K H file. And I look at that 100K H file and I get a migraine because I realize how much typing I'm gonna have to do. So what's nice is I wrote a little tool then that converted header files into peach definitions, and we can list that under tools that help you write your fuzzer. But not every tool gives you the ability to do that. Additionally, the language you write things in is wildly different. Some tools are in XML, some tools you actually write code, and some tools have some sort of made-up fantasy world definition language. An example of modeling in Peach, this is a very simplistic example, just to give you an idea of what some things look like, is in XML. And essentially with this example, all I'm doing here is I'm setting up a number length field in a string and building a relationship between the two. And you can see up here we have a number, we have a relationship element, and then finally we have a string. And hopefully that can almost be read and make some sense. In Sully you write things in Python using the Spike language from back in the old days, and it would look something more like this. We're going to build up functions that will end up being elements that we're going to fuzz. Now, one thing that kind of blew my mind when I was reading through the Sully docs, you'll note that our first element here, this size block, has a parameter says fuzzable equals true. And I don't know if this is a documentation typo that's fixed in the code. I don't use Sully a lot. But it says by default the size fields are not fuzzed. And that was a little like, wait, what? Don't we want to fuzz the size field? Scratch. Other fuzzers like the Art of Fuzzing. The Art of Fuzzing gives you a tool that lets you go into packets and place what they call like fuzz markers, where you can say, hey, this byte range is a fuzz marker. Maybe do something to that. Here's another byte range. Do something to that. GPF has probably the most arcane system for specifying kind of quote-unquote data models or interesting areas. And it's all almost command line silliness that I think you can go into a config file. It didn't really make any sense the first 3 times I read through how to do it, but you can do it. Another fuzzer like that's fairly popular, EFS, you don't actually build models at all. You give it a template and then it uses code coverage and static analysis to try and do some genetic algorithm stuff and fuzz things. Spike ends up looking a lot like this, except for it's in C. And Lord knows I don't really want to be writing fuzzers in C no more. And let's see, other examples. Fuzzware, the other kind of maintained general fuzzer, also uses XML and has a nice little GUI tool to assist you in building things. So the next step, after we build our model, before we run anything, we really need to validate our model. So if you were to spend, I don't know, a week modeling all of SMB version 2, including RPC over SMB, SMB over TCP and UDP, and you're just like, whew, this is gonna be awesome though. I've got this huge fuzzer for SMB, it covers every little crack and corner, this will be great. And you go and you run it without validating how it works, you're gonna lose. Because I don't know how many times I've come into an organization, looked at their fuzzer that finds no bugs, and this is a great hint that you did something wrong when your fuzzer finds no bugs. And looked at the fuzzer and said, hey, look, you have 2 fields with the wrong endianness, you have 1 field that's the wrong length, and if you'd actually run this through Wireshark a few times, you would have noticed it didn't really work. So I'm a huge fan of really pointing out that you need to validate, 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 which brings up a question of like, who has validation tools? Because honestly, validating isn't always really easy. Honestly, with network protocols, maybe you have a network dissector that's really good and you can use to validate, but it can help to have tools. And it turns out that there's only two tools, only two fuzzers that I know for definite have tools to help you. One is Peach and one is Sully. With Peach, you get two modes of validation. You get a GUI app that will allow you to parse something into your data model and show you what the parse tree ends up looking like. And you also get debug output from the program that will show you how the fuzzer is interacting with files and parsing things in network protocols. Sadly, for a lot of these slides, you will notice little question marks on the commercial fuzzers. And that's because it turns out getting information out of commercial fuzzing companies is rather difficult. In fact, Moo Security was the only company that called me back and answered some of my questions about their new product, which is completely different than some of their existing efforts. But I still didn't get great answers on quite a lot of things. And of course, because Konomicon pre-generates everything for you, there's no validation needed. It either works or it doesn't work. The next major thing that hopefully your fuzzer is going to have is monitoring support. So once again, in the old days, for the security researcher, hopefully all he really needs to hit is that one bug. And so how long it takes to hit that one bug is not necessarily as important. He's going to let that run for maybe a month or two, gets home from work, checks it, kicks back off, if it crashes, and continue on. But for us normal people in the corporate environment, our time is valuable. And we were hoping to make fuzzers offload some of that load and do their thing. So monitoring becomes very important. Monitoring is basically the idea of being able to attach a debugger to a process, automatically repin stack traces from crashes, and really important, restart the program and continue fuzzing. Because I'll tell you, like if you're under a deadline, there's nothing worse than kicking that fuzzer off on Friday, having it hit a no pointer exception at like 7 p.m. and stop. And you come in on Monday and you're kind of like, I'm going to have some bugs, and you're like, oh crap, freaking fuzzer hit a no pointer. It's no vulnerability there, and it stopped. So really, any fuzzer worth its dime these days should have some sort of method for taking network captures, maybe attaching debuggers, and doing sort of complex fuzzer setups. And one example that I'll use that I'm currently doing right now is I'm fuzzing parts of BlackBerry Enterprise Server. And so the way this tends to work, and it kind of shows the shine of at least Peach's ability to do extensible monitoring, is my fuzzing configuration looks like this. Now, my actual target is on kind of this pink haloed box, and it's the attachment service. So with BlackBerry, what happens, if you send your buddy, say, a PDF or a JPEG image via email, the first thing we do is we hit our email server, and then our BlackBerry Enterprise Server pulls the email and sends it to the BlackBerry device. Your buddy pulls up the email and says, yeah, I want to see the attachment of the pretty kitties. And the BlackBerry goes back and pokes the Enterprise Server and says, give me the attachment. And this little other service starts up and converts from like PDF or .doc or something into BlackBerry's proprietary RTF squeezy goodness and sends it to the phone. So since my target is that application, that attachment service, what I need to do is I need to inject email into the email server with my fuzz attachment on it. I need to have a debugger attached to the attachment service, and then I have software on the BlackBerry that has to request the email and then request the attachment and then notify my fuzzer that I got the attachment or we timed out. Now, if I don't have this type of monitoring support, what's going to happen is I'm going to sit there and I'm going to inject email, and I'm going to get completely out of sync because I'm probably going to inject email faster than my BlackBerry gets the email, requests the attachment gets converted or non-converted and comes down. And when things blow up and crash, I'm going to have no idea of what my input was to cause that crash. All I'm going to have is maybe a stack crash. And that's not useful. So having good support for monitoring, and especially extensible monitoring, can make your life a lot easier. And so I basically break that up into two classes of monitoring. The basic stuff is you got to have a debugger. If there's no debugger support and no restart support, don't pick the fuzzer. That's just the way it goes these days. Also, hopefully, if you're doing network fuzzing, you do network captures because why wouldn't you? Why wouldn't you? And then on the advanced side, you should give us a pluggable, extensible interface. And also, it's really nice to have VMware control. And with VMware control, when things crash, you can just poke the VM and say, oh, just go back to your previous state, and we'll continue fuzzing. So the question is, how many fuzzers do this? Well, it turns out that the large majority do debugging. The network, only one network fuzzer took network captures, aside from Peach, which is a general fuzzer. And aside from Sully, so Sully has specific support for VMs, but doesn't necessarily have a really extensible interface to add other things. And Peach, it turned out, and this really surprised me, was Peach was the only fuzzer out there that actually supported fully extensible monitoring capabilities. Now, for the bottom 3 tier guys, once again, I know Moo Security and there are some attached debuggers on multiple platforms. I know Moo Security takes network captures. I assume some of the other ones probably support that too, but I have absolutely no idea what their extensible nature is. So next, we have the fun task of actually running our stuff. And obviously, running is joined to the hip of the monitoring. And hopefully, we can get past our faults. But another big question is, can we run in parallel? And this becomes a fairly important question when you think about how many iterations you have to do. So the baseline Microsoft SDL calls for a minimum of 250,000 clean iterations. And what that means is that from the last time you hit a bug, you need to go 250,000 test cases without a bug. Now, I actually feel that that's fairly low. For example, if I model a somewhat complex format, and I was to fuzz that in a non-random way, which meant I was to fuzz every field with every value I can generate, some of the fuzz files I generate could be in the 5 million to 10 million test case range. I mean, they can be really huge. So if I am going to do a random sampling of those test cases, I really prefer having at least 500,000 test cases. Now, you can imagine if your test takes 30 seconds to execute, you're going to be sitting around for a very long time. Unless you can run that on, say, 10 or 20 boxes. And so we can go from 174 days down to 9 days. And hey, 9 days is a lot better than almost a year. So hopefully your fuzzer also supports running in parallel mode. And I kind of say that really all you probably need is the entry-level parallelization, which is maybe like 100 boxes maximum, which is pretty much good enough for almost everyone. At the higher end, there are systems that can scale more towards 10,000 nodes. And we call those the instant bug gun finding bug system thingamajings. In fact, hopefully you'll be seeing some stuff released in the next few months that uses Amazon EC2 cluster, and you can do things like, my budget for finding bugs today, $2,000. Then with machines I can fuzz on, 10,000. Click. Fun stuff. But for most of us, we really just need to be able to run at least 10 or 20 machines. In fact, it's very rare that I run fuzzers anymore, even at home, on less than 3 machines. And typically I prefer to have them on 10 to 20 machines, especially when you start pulling in different architectures. Like, gee, do I need to run my fuzzer on both 32-bit platforms and 64-bit platforms? The answer is yes. Why, you say? Well, you can imagine on 30-bit systems, if you need to overflow a 30-bit integer, probably not going to happen. On a 64-bit machine with 32 gigabytes of RAM, you have a whole new class of fun bugs that used to not be exploitable, now are exploitable. So for runs, here's kind of the breakdown of fuzzers. And kind of what I put down here is kind of the base OS supported. If you support kernel debugging, if we support symbols, if we can do parallel mode, and if we can do process restart. Now, under Windows debugging, the big difference between WinDebug and system is, hopefully everyone here has used WinDebug before. WinDebug is kind of more the advanced debugger for Windows. It supports lots of nice features and exposes itself as a COM object. So it kind of surprises me that there's really only 2 open source fuzzers that support WinDebug, and everyone else seems to use the system debugger, which doesn't support symbols, doesn't support kernel debugging, and doesn't support WinDebug modules to do things like crash analysis, which also tends to be very fun. Additionally, only 2 fuzzers that I'm aware of can be run in parallel mode, myself and Sully, which also surprises me a lot. Now, I mean, because honestly, doing a really basic parallel mode is really not that hard. All we really need to have the fuzzer layer is support to chunk up our test cases. So if we know we're going to do a total of 250,000 test cases or 1 million, we should need to be able to chunk those up and divvy them out to different machines. And yet currently, only 2 fuzzers will do that. I know Moo Security will not do that because you have to buy more appliances. I'm not sure about Konomicon or B-Storm. Results. So results are the things that make the smile on your face big until you open up your log folder and find 10,000 crashes. And you're like, oh, seriously? And then you start going through them and you realize that in batches of like 100 or 200 is the same bug over and over and over and over and over again. And you're like, crap, this is going to take me the rest of my life to figure out. Enter crash analysis. So the next thing that become extremely useful in your fuzzing life is crash analysis. The ability to bucket duplicates into buckets is the first level. The next level is doing some sort of baseline analysis of exploitability. And to help this along, Microsoft released some of their internal code that they use internally with fuzzing from the SWI tools team called Bang Exploitable. And Bang Exploitable is really neat. It was written by Dave Weinstein, who's a smart guy. And if he's around, he's usually in a Hawaiian t-shirt with a little fuzzy goatee. And you should go talk to him. And really what it is it's a plugin or a module for WinDebug. And when you hit a crash, all you do is hit Bang Exploitable, seriously, Bang Exploitable, and it will go through and it will bucket and do taint analysis tracking. It has all these little modules of like, do we hit a dep exception? Does it look like a stack overflow? Was our tainted data used in a branching condition? Is it a null pointer exception that looks exploitable or non-exploitable? And it'll end up grouping your stuff up. And at the top level, they'll say, this is more than likely exploitable, and you might want to fix it. Probably exploitable, not likely to be exploitable, an unknown condition. And then the next level, it'll say, well, we don't really know what this is, but our taint tracking says that we used some sort of bad value in a branching condition that led to like a read AV. We don't really know if that means it's exploitable or unexploitable, but you should check it out. The next level is it gives you a minor and major kind of like hash IDs that is loosely based around the stack of the program for grouping, bucketing exceptions together. So if you cause the same exception, even if you cause it through some other weird paths, it tends to be bucketed in the same manner. And this is a huge lifesaver. Because first off, your testers can pretty quickly say, if they're not like experts at IDA or loading up and analyzing exploits, if it hits the most likely exploitable bucket, they can at least log that as a Sev1 for later research and pass the other things along to devs. So in terms of grouping duplicates, I do not know if Sully does this. I suspect it probably does. I do know that Fuzzware will do some very basic grouping of things, mostly based on the last stack point and the exception code that you hit. And Peach is the only one right now that does any real crash analysis that I can find. So adoption risks. So I had this really interesting phone call with a company that wanted to pick up Peach. And before they picked up Peach, they wanted to talk to me. And they started asking questions like, what happens if you die? And I'm like, what do you mean what happens if I die? They're like, well, what happens to Peach? I'm like, I don't know what happens to Peach. I don't know. And they're like, well, who keeps developing it? Do you have commercial backing for it? I'm like, I don't have any commercial backing for it. I don't make any money off this stuff. They're like, okay, well, how many developers are on this project? I'm like, me? And they're like, oh, really? Note taking in the background. I'm like, oh, gee. Wait. I have forums. I have other people who use it and contribute code. They're like, oh, okay. Check. And it would really kind of open my eyes. I'm like, wow, hey, these guys are smart because they're asking the right questions. How long do I plan on developing Peach? Do I plan on keep writing new versions of Peach? What's the support model like? Can I email you bugs? What's your turnaround time frame? Is there a forum that other users contribute feedback to and can answer my questions? And of course, the other one is, do you offer training? And I'm like, well, yeah, I'll give you a training class, sure. Show me the money, and you have training. But it was kind of interesting because a lot of companies don't put that kind of time thought into picking up fuzzers. Sure, maybe you put that time thought into paying for the $100,000 router, but maybe not so much for the fuzzing. But really, I think you should, because it turns out that really taking fuzzing and integrating it creates a large dependency in your organization. You're going to end up possibly writing a lot of models, some extra code bits. You're going to have training a lot of developers or testers on this, and you really end up picking up a real product. So hopefully you should be asking questions like, what is the sustainability of this tool? Was it simply written for a conference, or will it exist further on down the line? When was the last release? Do you have commercial backing? Do you have active leaders? Is there a mailing list? It's amazing how few mailing lists there are for fuzzing. In fact, there's only one general fuzzing mailing list that I'm really aware of, and it gets like one post a month. And it turns out that pretty much none of the other fuzzers actually have forums or active community. Peach, as far as I can tell, has the most active, and it's not super active, but I'm amazed that people will actually post questions, because it used to be a year or two ago, if a question got posted, it was always me replying. And recently now, it's gotten to the point where there's actually a lot of other users that reply, start answering these basic questions, and that makes me happy. But quickly going down here, you can start seeing some obvious patterns in version numbers and when code was released, and also how long the fuzzer was available. And you'll see the majority of these open source fuzzers haven't been touched since like 2007, at least for the ones that weren't extremely custom one-off ones. You'll also see that most of the version numbers are fairly low, not much activity. And in the case of Soli, it doesn't really have a version anymore. You just kind of check out whatever's there. Now, obviously, the commercial fuzzers, they kind of win out in this regard. We know they have commercial backing. They probably make some money. Some of them have been around for a long time, and they're always pushing out new versions. And for them, they have support, they have training, and all that good stuff. The next thing is maturity or usability of the product. And this is one of those things like, how many real versions has your product gone through? Are you still the fledgling, fuzzer that hasn't put a lot of thought into what it's really doing internally, or have you been through a few major revs? Do you have online support? Publications, is there a book published to teach me how to use this? Are external users a priority to you? That ends up being a huge, huge question. There's a lot of people who publish fuzzers who don't really care if other people use them. They think that's great, but they don't want to hear from you. They don't really want to support you, and their intention was not to create a fuzzer that everyone in the world would use for everything, unless you're super smart and can fix it yourself. The next one is support and training. Now, if you're the super uber hacker out there, and you're like, oh, training, who needs training in fuzzing? Fuzzing is easy. But realistically, for company adoption, training is a big question. Really doing these things correctly and integrating them correctly and learning how to use them, especially the advanced fuzzers, it can actually be a challenge. I spend 2 days cramming Peach into people, and hopefully around the second day of doing labs, you start seeing lights up and kind of like, okay, I think I get what's going on. But still, even with 2 days of training, a lot of people at the end of the day are still like, well, all right, it kind of starting to make sense, but I'm going to have to take this home and play with it because there's a lot of stuff going on. And then support. Man, if you integrate this into your SDL and you hit some major roadblock, is the developer going to respond to you? Is he going to say, yes, that's a feature for 3 years from now? What are your options there? So can you purchase some support from him or from that company? Another big one is license restrictions. Who here works for a company that restricts the use of GPL? Anyone? I see a few hands going up. This is becoming more and more of a problem. Are companies who don't like to use GPL software because they're afraid of the Free Software Foundation lawsuits. They don't want to have to deal with tainting issues. They don't want to have to deal with releasing the code that they write on the web. Then there's always these questions of, well, if we check it into our code tree, so it goes onto the build boxes and can be run automatically, does that mean all of our code is GPL now? That's a question. If the developer does die and we have to continue development of this fuzzer, what does that mean? I don't know. So suddenly licenses become a big deal. And I ran into this early on in Peach development. So personally, I'm not a huge fan of GPL because of all the restrictions it places on you. When I do GPL stuff, or when I code on GPL projects, I kind of feel restrained a lot. There's a lot of things I have to make sure that I do to protect myself. So I prefer things like BSD and MIT, and so do my customers. So with Peach early on, I quickly found this whole thing has legal approved use of your, because you say open source, you're like, oh, you're GPL. We can't use GPL software. Or has legal reviewed our use of this in our development system. So that's a big question. Now, typically the commercial licenses you pick up from a commercial product are going to be fine. But with the open source ones, you're going to want to have, you should ask yourself, what does happen? What happens when I extend this? Who's going to put the code on the website? Will that give away company secrets? So another thing I have is I have this little table of adoption risks. Now, the sustainability and usability numbers are very subjective. I just kind of went through and kind of like, well, all right, Sully has a book published, 4. Peach has a nice wiki and a training class, 4. Spike has header files, 1, and so on and so forth. Now, you'll notice that under sustainability, I really didn't give any of the open source fuzzers sustainability above 3. In fact, I don't even know why I gave Sully a 3, considering it's not really sustaining. And the reason I did that is because most fuzzers in the open source market have 1 developer. None of these projects have really grown huge. Like, probably if Forador were to die, Nmap would continue on. There's a lot of people that contribute to Nmap and want to see it continue on. Wireshark would probably continue on. But I really don't know if Peach would continue on if I died. Chances are it wouldn't, not the way it has been. So that's an issue for sustainability. It also turns out that no other open source fuzzer except for Peach offers like actual training and support, which I actually kind of found odd. I'm sure actually if you ask them, they'd probably do something for you, but it's not a standard offering. And of course, with all the commercial fuzzers, you're pretty well off. So costs, that's the next big question. So here's the time you will spend fuzzing in order. The first longest step is modeling. When you get your open source fuzzer, the first thing you have to do is tell it how to fuzz your data. And that can take a while to really do. It's also the largest learning curve of fuzzing. The next one is monitoring. If we don't have good monitoring support, that's going to heavily impact my run times and my usage of time. Or if the monitoring is finicky or broken. Or if I don't have crash analysis. That'll be the next one. Is it exploitable? Is it a duplicate? How many crashes am I finding and how long will it take me to sort through them? So the things, obviously with modeling, you get that for free with, or not for free, you pay for it, but that's pretty much you're paying for with, upfront costs for commercial products. So you might ask, what are the upfront costs? So with open source, obviously, you get suckered in because it's free, and then you spend a lot of time dealing with that fact. For Konomicon, for 5 days, for $5,000, you can test 5 protocols. And then it goes up from there. Now, you're just getting the test files themselves. With Moo Security, for $50,000, you get a box, 10 protocols, and 12-month license. If you want the whole thing, $250,000 is the last price I heard for 50 fuzzing protocols. B-Storm is $15,000 per module. And what that means is they kind of tend to group things together. Like you'll get the graphics module, or the core internet protocol module, or this module or that module. So we can see that we're going to have some significant upfront costs if we want to integrate these fuzzers into our SDL. So the question really comes, is it worth it? Is it worth getting that level of support or getting all the fuzzers written for you versus doing them in-house? And that's a real question, because it does take real time to write these models and adopt fuzzing. And the hidden cost for the open source, as I've kind of been saying as we go, is the ramp-up time, the modeling, the crash analysis, and that's what you pay to avoid. And so who is the winner? Well, I don't know. That is up to you to decide. But I hope you've enjoyed this presentation. I hope this gives you a great idea of how to adopt fuzzing in your organization and what questions you need to ask. And with that, I hope there are questions. Does anyone have any questions? Something I haven't covered they'd like to ask? And I can almost sort of see. Right up here on the green. What's that? The question is, do I plan with Peach to have greater support for Linux? The answer is, I support Linux. My biggest detractor to Linux is that debuggers on Linux and Unix in general suck. GDB is a horse show. There's no real cross-platform way of using it programmatically. So pretty much my limitation on Unix right now is I use VDB, which is a virtual database abstraction layer written by, who was that written by? Kenshoto. But it was never finished to futility. It has issues on Solaris, works great on Linux. So I do support Linux, but it's just not nearly as nice as Windows. Other questions? Back there, shout it out. Are you asking if I can just take a network capture while you're fuzzing? To the fuzzer? All right, so the question is, can I connect the fuzzer to like a network capture? And pretty much I think what that question is can I make Peach a proxy? Is that what you're saying? I saw maybe there was a head shake. And at the moment, no, but it's been a planned thing. And actually I have a group of 35 students working on making that happen. And the way this will work is it becomes a proxy and uses dissectors, like the Wireshark dissectors, to inspect packets and then fuzz them intelligently. Currently, what you can do is if you export your fuzzer, your Wireshark definition to PDML, I have an analyzer in Peach that will try and convert that to data models. And then you can go back and add relationships. Any more questions? Anyone? There was one. So the question is, if we're fuzzing some protocol or some field, and after the first 100 days, every test fails, should we stop fuzzing that? And Sully has a feature to say, after a number of crashes per field, stop fuzzing that field. I think that's an arguable one. I think if your mutators are developed in such a way that they do very specific things per mutator, like the length mutator or the Unicode injector mutator, you should be able to say things like, if that one mutator causes that field to crash continuously, then stop using it, yes. I would certainly not want to say, stop mutating that field, because there are other mutations that may cause completely other issues. Now, the nice thing is with bucketing, it becomes less of an issue. If you can bucket all of your exploits together so that all the recurring ones occur grouped together, then the only real issue you have is time sync, is the time it takes to take the crash dump, to do the analyzation, and to log it. Otherwise, it really has no impact in your life other than you have 10,000 ways of exporting a Stack Overflow or 10,000 repros. Any more questions? We got one over here. Instrumenting debuggers as for fuzzing. And perhaps you're referring to the Google released GCC plugin? Yes, he is. So this is an interesting one. So there's this whole new group of fuzzers that do things like static analysis, dynamic analysis, that get integrated with compilers. Sergio out of Germany is doing in-process fuzzing. And I think that anything that finds bugs is good. Obviously, if you're integrating the GCC, you have a very small field of usage. And you also have to ask yourselves, well, what can it really do? What are its limitations? Its usefulness may be boxed. I've seen some that do dynamic analysis, and basically build a graph of every decision tree that occurs on the data that you input, and then use this graph solving to try and hit new blocks. The problem is, we call it a fuzzer, but it doesn't really fuzz. What it does is it dynamically finds blocks and then has logic rules on how to find exploits that may occur. Because while you may be able to get to that block, you may not be able to get to that mem copy with a long string, but it can get to the mem copy, but then it has logic to say, oh, we got to a mem copy that might be exploitable. So I don't know, it's a toss-up. Hard to say. Any more questions? Anyone? Bueller? All right, cool. Thank you all for coming.